All right, so here is question 27. Question 27 says, explain whether the formula of CuO can be used to represent both copper 1 oxide and copper 2 oxide. So let's write the formulas, right? The Roman numeral is just telling me the charge. So these are both copper oxides, CuO and CuO. But now I got to find the charge. Copper Roman numeral 1 means +1. Oxygen's charge I can find on a periodic table. I just got to look it up. I've got it marked in on my periodic table at the back of the book, right? Oxygen is -2 for life. Okay, so let's say I want to write the final formula then. I have two options. I can be a charge balancer or I can be a crisscrosser. But no matter what, you have to find the charges. And eventually you might be so good at this that you don't even have to write them on paper. I mean, you don't have to show work for this. But if you can't find the charges, then I don't know how you can write the formula. Okay, so if I'm a charge balancer, then I'm looking at this and saying, how do I make it add up to 0? Ionic compounds should be neutral. So I've got a +1 and a -2. Complex math would say that maybe I'll take 2 coppers. If I have 2 copper ions, that would give me a +2, and that would balance the -2 from the oxygen. +2, -2, that is neutral. And then the multiplier just becomes my subscript. So if I had to multiply copper's charge by 2, then I need 2 copper in my formula. Cu2O. Now one thing that's really important to note here is this is a common boo-boo. The name of this thing was copper 1 oxide. And often people will think that by saying copper 1 oxide, it means like 1 copper, like 1 atom of copper or something like that. And so then they're like, what? Why do you have 2 coppers? Oh yeah, because the Roman numeral is the charge. It's not the number of atoms in the compound. It's just telling me that copper's charge is +1. Then I have to see, what's that +1 charge bonding with? Oh, it's bonding with a -2 oxygen. So what that means is that copper would like to donate 1 electron, but copper needs 2. Oopsie, oxygen needs 2, right? Copper donates 1, oxygen needs 2. So if I have 2 atoms of copper, then I can donate 2 electrons. Oxygen will take them both. Done. Game over. Everybody's got a full outer shell. Now you could also be a crisscrosser. That's fine too. You'll end up with the same formula. If you're a crisscrosser, you'll just crisscross the 2 and the 1, and you'll get Cu2O. So whatever you're more comfortable with or confident with, you just have to find the charges. And then obviously if you're a crisscrosser, you don't have to write the 1 behind oxygen, and you don't bring down the plus or minus. Okay, so now if I'm copper 2 oxide, the Roman numeral 2 is the charge. So now copper's charge is +2. Oxygen is always -2. Sweet. If you're a charge balancer, you're going to look at this and say, duh, +2 -2 adds up to 0. This copper is going to donate 2 electrons, and copper needs, or I should say oxygen. I did it again. Oxygen needs 2. 2 electrons donated. Oxygen can take both. Done. It's neutral. It adds up to 0. That's the formula. CuO, 1-to-1 ratio. Now, if you are a crisscrosser, then initially you might crisscross and say Cu2O2, but then we say, oh, wait a second. In an ionic formula, ionics are always like metal, non-metal. In an ionic crystal, we report the formula as the simplest repeating pattern. And so we would never leave it as 2-to-2. We would simplify that to a 1-to-1 ratio, CuO. which is what the charge balancers are going to say right away. Either ends with the same formula. They're both fine methods of getting the ionic formula. But again, the name of this thing was copper 2 oxide. But there's only one atom of copper. The Roman numeral is the charge, not the subscript. And so it says, explain whether the formula of the CuO can be used to represent both copper 1 oxide and copper 2 oxide. We're going to say no way, right? No way. No, CuO is really only copper 2 oxide. Because again, if I were given the formula, and if I had to write the name, well, I know that it's copper and oxide. Before I say I'm all done, I look at the periodic table and then I see, ooh, yeah, copper's in that middle transition group. So I'm going to need the Roman numeral to indicate the charge. Then I'm a freak with charges. I know oxygen's charge is -2 for life. And so if I have to make this neutral, then the copper must have been +2. Copper Roman numeral 2. If I had to go backwards and I was given the formula and I had to write the name. So no, we cannot say that the same formula can be represented by both copper 1 and copper 2. They're different formulas because the charge is different.